Hi everybody, in this video we will be looking into hashing, generate SHA-256 using Java, hash collision and applications of hashing algorithm. Let us start our discussion with hashing. A hashing function is an algorithm or mathematical formula that transforms input data of any size into a fixed length sequence of numbers and letters. Let's understand hashing function by taking few examples. First, let's take a single character as an input, pass it through the hash function. It will going to generate a random sequence of numbers and letters. Secondly, if we pass an entire paragraph through the same hash function, it will still generate a random looking sequence, but this time the output will be different from the one generated by the single character. Third, when we input a full page of content and apply the same hashing function, the output will be again a random sequence of characters, but crucially, it will be the same length as the outputs for the single character and the paragraph. Finally, if we input multiple pages of content, the hash function will still produce a fixed length sequence regardless of the input size. This randomly generated output of fixed length sequence of characters is known as digest or checksum or hash value. From the example, we can observe the following key properties of hashing function. First, it is highly unlikely for two inputs to produce the same hash value. This is known as collision resistance. Second, hash functions are designed to be irreversible, meaning it is computationally infeasible to retrieve the original input from the hash value. Third, a small change in the input, even a single character, will result in a completely different hash value, demonstrating high sensitivity. Fourth, regardless of the size of the input, the length of the hash value remains constant. Fifth, the same input will always produce the same hash value when we pass through the same hash function. Sixth, the hash functions are designed to be fast, ensuring that the digest is computed quickly, even for the large inputs. Let us use Java as a programming language to hash any string message. Let us start by defining the same. Now, Java provides a class named MessageDigest which belongs to the package java.security. This class supports algorithms such as SHA-256, SHA-384, SHA-512, etc. to convert any arbitrary length message to a message digest. Here we need to define the algorithm. In this example, I am going to use SHA-256. Now this method we're going to throw an exception. Let us define the same. Message digest has a method named digest which accepts bytes of the text which we want to hash. At this particular stage, we are already having our digest in the byte form. Let us write the following code to convert this byte message into the hexadecimal string. Here, %x stand for hexadecimal format. Now, let us try to execute this code, and we are having some hexadecimal value. Now, as per the property of hashing, if we execute this code again, we will be going to see the same result. Now, let us try to alter this particular string a little bit and execute this code again. It should return totally different digest. As we can see, after adding just a space, we are having a totally different result. Let us start with hash collisions. A hash collision occurs when two or more different input messages produce the same hash value or digest. Now question is, why do collisions happen? Collisions occur due to the fundamental property of hash functions. They produce a fixed length output regardless of the size of the input. Since output space is limited and input space is virtually infinite, it's mathematical inevitable that different inputs may occasionally result in the same hash value. For example, MD5 produces a 128-bit output, which means there are 2 raised to power 128 possible combinations. Once this limit exceeded, collisions are guaranteed. SHA-1 hash produces a 160-bit output, offering 2 raised to power 160 combinations. Despite having more combinations, the possibility of collision still exists after a certain point. A well-defined cryptographic hash function is collision resistant, meaning it should be computationally infeasible to find two distinct inputs that generate the same hash value. However, older hash functions like MD5 and SHA-1 have relatively fewer combinations, that is 128-bit and 160-bit, which makes them more susceptible to collisions. This vulnerability is why MD5 and SHA-1 are no longer considered secure for applications like data integrity verification or cryptographic security. To minimize the risk of collisions and improve security, more robust hash functions such as SHA-256, SHA-384, and SHA-512 are now widely used. These newer algorithms produce significantly larger digests. For example, SHA-256 generates a 256-bit output. SHA-384 produces 384-bit output, and SHA-512 produce 512-bit output. The larger bit length drastically reduces the likelihood of collisions, making these functions far more secure for ensuring data integrity. Finally, let us jump into applications of hashing algorithm. There are various applications of hashing algorithm. Firstly, it is used in the data integrity. Second, it can be used in the password storage. Third, it is widely used in blockchain. We are also using hashing functions in version control systems like Git. URL shortening is also another application of hashing functions. Hash tables are widely using hash function algorithms.